Welcome to the Time CNC Podcast, your go-to show for precision, efficiency, and innovation in CNC manufacturing. We're here to help you cut time in all of your CNC endeavors. Whether you're a CNC enthusiast, CAD/CAM aficionado, or into robotics, this podcast is for you. Join us as we explore cutting-edge perspectives on machining metal parts. Discover the perfect tools and streamline your production processes. Precision meets progress on the Time CNC Industry Podcast. And now, here's your hosts, Al Martins and Stephanie Bate.
Hey, Stephanie. How's my co-hostess?
I'm good. How are you?
I'm doing great. Good. Another beautiful Wednesday night. I want to thank everybody for joining us tonight. Tell us, Steph, who's coming on and what are we talking about?
Well, we have a very exciting episode, Keith Leonard, and we're talking about mastering machining tips for efficient metal part production, which I'm excited to learn about because
I can see it in your face. There's so much joy. Everything you ever wanted to know about metal cutting. Well, that's great. Well, thank you, Steph. You're in the back watching, making sure everything's working. Let's get Keith.
Bye, everybody.
Hey, Al.
Hey, Keith, how you going?
Not too bad. How are you doing today?
Yeah, doing great. Doing great. Wonderful to have you on. Thank you for joining us. I know we've had this planned in our calendar for a little while, but once you go live, there's no going back.
Yeah, doing it now.
We're doing it now. Well, that's super. So, Keith, you're tell us about you and about where you are and what you're doing.
Well, I started in this trade about roughly 25 years ago now. Have my ticket for 21 years. Worked at several different shops, from general machining to die mold shops to, mostly general machining. And then I started my own shop in 2006 and been working for myself ever since. I worked for you for a little bit with Gibbs, and that was a great experience. Got to see a lot of different industries when you're not just always in one shop every single day, right? You get to go out, see other people, see other techniques. It was good for growth. Definitely.
Yeah. That's it. That's an interesting journey. So, how did you end up getting your becoming a machinist? What drove you there?
Well, I took it in high school, in grade 9, and then just kind of I liked it, and then just took it throughout high school and did a two co-ops, I think, during high school. I had different shops in the Niagara area and just decided, this is what I wanted to do. I really enjoyed making things.
I think that's what the theme is with everybody we've spoken to, and no different than myself. It's something about, getting in front of a design or an idea and wanting to bring it to life.
Yeah.
Right.
And the different challenges you go through to get to the end product. And
did you get any grief from people saying, "Why you want to be a machinist? You're a smart man. Go to university and waste your time"? Did you get any grief that way?
Yeah, several high school guidance counselors told me that, shouldn't go into the trades, but I just decided to do what I wanted to do. And yeah.
Well, what advice would you give young men today, young women today who are in high school? How would you direct them?
Well, I would definitely look into the trade. I could probably speak for every shop out there. They are looking for people and are willing to train people. And you can make a good living doing it. And it's a very fulfilling job every day. Like, when you go home, you don't want to build anything else. You know, I don't feel like taking the bathroom apart when I get home. I've already built everything I need to build for the day.
I feel like taking the bathroom apart. That's
You know, some people I know, they work in offices all day, and then they're always taking their house apart when they get home, and I don't have the need to do that.
I wonder how qualified they are working in an office all day. I'm not sure how that works.
Yeah.
Well, that's great. And I would say exactly the same thing. And I said the same thing to my own kids. You know, if you're going to go to school so you know how to work with your hands. And, you know, legacy always tells us that. Get your trade first. And, you know, you have something you can make money with, raise your family. And if you want to learn some other things about art or history or some other stuff, then, hey, do it on the weekends.
Yeah. And I find with our trade, especially because you kind of get a little bit of a electrical background, some hydraulics, some pneumatics, some machining, obviously, but there's a lot that goes into machining that I don't think people actually realize everything that's going on all the time. And, you know, you're very well-rounded to build pretty much anything after that. You know,
yeah,
you work with different trades as a machinist. You're not just, you know, an electrician every day or a plumber every day. You're doing different things. So,
you know, I know some machine shops that they don't even have a sign outside their building saying they're a machine shop, because people will just bring anything to them to repair, because they know they can repair anything.
Yeah, they'll just bring anything and everything. Yeah.
Farm equipment, you know, broken dental chairs, whatever they got.
Yeah.
They'll bring into the shop.
Yeah, oh yeah.
So what was the journey like then to end up starting your own shop? What could you tell people about that?
It was a long journey. One of the places that I worked at, there was two partners there, and their vision was to have myself and another guy eventually take over as time went on. So while we worked there, we were always kind of treated it like it was ours, like it was our place, right? It wasn't just the place we worked. But then that partnership soured. Everything kind of went sideways, and we ended up both leaving that place. And after going through that thought process to buying the business and operating and all that kind of stuff, it just kind of, I was already there with that thought process to kind of do it myself.
It was
it's not easy machine shop, but
okay. Well, then what did you do? Did you buy a shop? Did you?
No, I started in my parents' garage. I purchased a CNC mill, and I put it in there, and I had some work, small production work that ran every month that covered the payments of the new machine, and I made a little bit more. I still worked at that time for another shop during the day, and I did this at night and on weekends until I built it up enough that I could just eventually, enough was enough. Quit the other job and then take it from my parents' garage to industrial unit and then grow from there.
So what did you do for electricity? Did you have some kind of phase inverter, or what did you do?
I did have a phase inverter. In the beginning, yeah, there was a phase inverter. You had to turn off the hot tub to turn on the CNC mill at the same time.
You know your parents love you.
Yeah, exactly.
And if I remember, didn't your mom and dad run the machine for you?
Yeah, my dad did. He still does, actually. He still comes in. It's here today. Yeah.
Isn't that great? Isn't that great? So you really had some support from the family, and you got started in the garage.
Yeah, got started in the garage. A lot of support from family. So
that's fantastic. I guess that speaks a lot to new people getting started. You know, it's a lot of businesses get started in the basement, but I'm sure there's a few that gotten started in the garage too.
Oh yeah.
Yeah, super.
It can be done. It can be done. And I still have that machine in my shop. It's running today, making parts.
Not great.
Yeah.
Well, good for you. All right, Keith. Well, we've got traditionally 10 questions we go through. We've got a little bit of your legacy. Maybe before we get too far down the road, tell us about your company. Tell people about where you are and what company it is, and plug away.
Yeah. So KEL Tooling, we're located in Welland, Ontario, and we do everything. I shouldn't say our main, but is drop forge tooling, hot forge tooling, upsetter tooling. We do machine for oil and gas, forgings, valves, and now we've also started into automation for transfer presses, and it happens to be all aluminum parts and lots of them. So a lot of exciting things coming up there with that customer, and may lead to some robots and mill turns, hopefully, but just keep going along wherever our customer sort of dictates we need to be and servicing them. Yeah.
Well, that's exciting, Keith.
Yeah.
All right. Well, let's get into the tips for efficient metal part production. You're going to give some secrets away to a few people, hopefully. So our first question, Steph, is what are the key factors to consider when designing metal parts for efficient production?
So I was looking at this one. I think the main thing that comes to mind as a machinist and a tool maker is a lot of guys design parts that without the cutting tools in mind of how you're going to machine it. Whether it be corner radiuses are really small in deep pockets that don't necessarily need to be that way. Even to some parts where you could make the slot could be a little wider. It's in the air. It doesn't actually do anything. It's like a structural sort of part. If you made it a little wider, well, you could use a bigger cutter, and instead of doing it in smaller cutter and 3 or 4 passes, maybe you get through with 2. That design aids a lot to getting the cost down in the manufacturing of the part. And another thing I was thinking about too is they never really think about how you're going to hold the part. They can design some parts and they're pretty wild and crazy. And then how are we going to hold this? How are we really going to fixture this and make and hit all those critical dimensions?
So, it's interesting you say critical dimensions, because oftentimes some of the tolerances seem a bit odd for a clearance hole.
Yes, very tight. And sometimes it's not even a nominal off-the-shelf drill size. So now you're looking at it going, well, I could maybe hit the tolerance if I use the, ordered like a metric drill in this increment, or if it's a clearance hole, it should be the proper clearance and the proper thing, But and the other thing I think is a lot of guys that are designing now, they get really carried away with the radius function in their SolidWorks. They really like the radius and all the corners and make everything nice and smooth and everything. And there's a cost to making the part look exactly like that. It takes time to put all those radiuses on.
Oh, absolutely.
So if a chamfer is better, then get away with a chamfer. Yeah,
absolutely.
Fancy blend rad that flows out on 3 different walls, and then it's like, wow.
Is this
you can do that?
Really needed for the part? Yeah.
You don't really need it. So that's one of those things,
So in situations like that, let's say in quoting a job, do you talk to the engineers first and you say, hey guys, I can build the part the way you sent it to me for $10,000, or I can make it for $1,000 if you make these changes? Does that conversation ever happen?
Yeah, all the time. And especially with some of our customers that we're closer with. And they're usually pretty receptive to that idea. Like there's some stuff where they get carried away and you just kind of bring them back a little bit and everyone's kind of happy, especially if it's going to be a part that's going to run maybe you run 100 this month, another 100. Like if it's a production part, then maybe, yeah, you really got to look at maximizing it.
Yeah.
So sometimes the design has to give way a little bit to the practicality of making it.
I think, in the end, for young machine shop owners or guys going into the business, especially the younger ones, they shouldn't be afraid to, before they even quote, to talk to the company and say, hey, this part would be way more efficient if we make these design changes, and not necessarily just say, well, hey, this is how they sent it to me. This is the solid model. I got to make it exactly what they want, right?
This is what they want. This is what they said. Why aren't we getting any work?
Yeah. Why aren't we getting any work?
Yeah, because the other guys are getting in there and
doing the due diligence, right?
Yeah.
Super. Okay. Well, that runs right into how does the choice of materials impact the efficiency of metal production? Let's talk about materials.
Yeah, I guess materials, they spec them out for whatever reason, but one of the ones that comes to mind that happens a lot with us is they'll want to use like just say a 1045 steel, but then they want to heat treat it up to 32, 34 Rockwell.
Okay.
But now you gotta, you're going to heat treat it. All your holes are going to move. Everything's going to move. So you got to bring it all back but then a couple of my customers, I say, why don't we just use the 4140 pre-hard?
Right.
It's already 34, 36, and we'll just make the part. Oh, it's too expensive. We want to use this cheaper material. I'm like, but it's not more expensive.
No.
If we just do it, we just machine this. Yeah, the material is going to be more, but my time is going to be a lot less, and the machine time is worth way more than the material.
Sure. You got heat treating, you have annealing, you've got the whole process that they have to add to that.
Yeah. And then you have shipping it back and forth to heat treat, the time that takes.
Yeah. So that's interesting. So you speak to customers not only about design, but also about materials.
Material selection. Yeah. And more so that comes into play with the forge dies, different materials to try to get higher die life and things like that. But that's a little more, I would say, extreme than the regular guy just wanting to use a material and harden it just when you could buy it off the shelf already.
And I guess it's really not a lot different than people who are running, let's say, small batch runs of a mold, whether they may decide to just cut it in aluminum. We were only doing some prototype molds, or they may decide to cut it in tool steel. D2 or something like that, right?
Oh yeah. Like it's the same thing. And just you're helping the customer out based on what they really actually need.
Absolutely. All right. So let's get into what are the most effective technologies and machinery for producing metal parts. Now that's a really kind of broad question, but
I was going to say that one's pretty part dependent.
The most effective machinery is the machinery I have in my shop.
Exactly. The ones that we can afford. Yeah.
Yes, exactly. Yeah. So how do you tackle that when a customer comes up with a part, and do you look at your machinery and say, hey, we've got all the equipment we need, or how do you manage that? What do you do?
Yeah. When we're first looking at the part, I automatically, we don't have any 5-axis here. We have horizontals, we have verticals with rotaries. So I kind of look how I can put it in the horizontal is always the first. If I can get it in here and hit as many sides as I can, but ideally, in a perfect world, you'd have a nice size 5-axis machine, and away you'd go. If it didn't fit in there, you put it on your mill turn, but it's not always the way. So yeah, we kind of look at what we have and plan the job and quote around what we have. Unless it's a very large quantity, then you can look at, adding a piece of equipment. But other than that, just try to figure it out. And that, I think, is one of the things that I still enjoy in the trade is, you got to figure it out every day, and you're thinking every day and you're learning something every day. So again, it goes back to kids that are getting into this. It's not once you learn it, you're done. We had a co-op kid here one year, and he said that he could probably learn the trade in 2 weeks.
Oh, of course.
He's like, it seems pretty easy. You just put the parts in, you push. I'm like, it's a little more than that.
That's the generation we're living in.
Yeah. He watched, a couple of YouTube videos, and he was ready to go.
Yeah.
After the 4 months, he's like, I can't even come close to learning what you guys know in here in, 5 years.
Can they even clock a part,
No.
How about taking a tool offset,
Yeah. No.
No, exactly. Yeah, that's getting harder to find. That's for sure. Well, in the machining side of things, now that there is, the choice of machines are so large today. It becomes almost a puzzle to figure out what is the right equipment. And I think, as you said earlier, depends on quantities as well. Do you get a mill turn machine, or might you be better off with a screw machine? Do you get a Nakamura? Do you get a Turnos? Do you have to make 100,000 of these things, or do you have to make 8?
Yeah. You really have to define what your shop's looking to do, what batch size your shop's looking to do, and sort of stay in there, because, as you know, it's so expensive in this trade. Everything we touch is always thousands of dollars, and it adds up very quickly. And it's hard to really pick equipment. It's very difficult to pick equipment, especially as a jobbing shop. And a jobbing shop owner, you're trying to, when I look at equipment, and I think of every scenario that I could put work onto it that I already have, and how I could grow my business with it. And then you always, unfortunately, as a jobbing shop owner, you always come back to that big 5-axis machine. It's like, well, I need this. Well, it would be nice if I could just turn the part, and then, yeah. So I see the 5-axis machine is obviously going to be immensely more popular in the future with pallet pool and lights out machining.
I agree. I used to be the day where you had a 2-axis lathe and a 3-axis mill, and you'd move parts between machines.
Yeah.
Those days are
gone.
Yeah. They're pretty much a memory. Although, offshore, there are many companies who produce parts like that and send them back to us. We wonder how they do it. So it's still possible, but obviously your labor rates have to be almost zero.
Yeah. And we're actually doing that with a part right now, and we're just growing with that customer to the point where I can get the mill turn with the robot. We just keep going, and we're going the hard way, but you can't just run out and spend, 1.2 million. Yeah.
That's an extreme machine, but at least $500,000 for, depending on the size of the part.
Yeah.
And what kind of load unload you want.
Exactly. And, the math all supports it. When we're looking at it, we're picking it out, and it's like, it's almost a no brainer, but I just, the volume isn't there yet. So we turn them on the lathe, and then we load them in a 4-axis mill and do as much as we can. Yeah.
So that kind of leads us into what are the most effective technologies and machinery for producing metal parts quickly.
Yeah.
That really kind of a tangent conversation. What are your thoughts there?
Like which?
Well, I think about the technologies, I'm thinking about, is it really valuable to have a machine, let's say, with probing?
Yes.
Yes. Okay. Well, there are those who say, well, in machine probing is certainly not as effective as having a CMM machine, for instance. Which do you invest in first?
But the same part that we're talking about, moving from the lathe right now to a fourth axis. We move it to a fourth axis, and actually, I have the part here.
Oh,
Which
nice.
is what I was showing you before, but it is already anodized, so it's hard to see. But I can hold it up to the camera.
Yeah.
This is quite important. And so is this slot in the back here. It's kind of hard to see. Sorry, it's anodized.
That's okay.
But of course, we hold it up there. We turn it on the lathe. We flip it over. We turn it on the lathe. And then we put it in the fourth axis. Well, how do you hold a thou over this flat when you're in a collet chuck? You can't have a stop out here because we're coming in from the end. So we come in and we probe every single one. We run thousands of these parts, and we hold the tolerance all day. And then after, when we stand this part up, because these two pins,
right, the location pins, this actually slides into a block. So it locates on this bore, locates on the two location pins. And I don't have one here, I don't think, on my desk. But there's actually an electrical connector that goes in there, and there's 6 prongs. So this all plugs in. There's also another air fitting attachment with 2 prongs on the top. So this all all these cylindrical bores have to line up. So after we probe the end, we stand it up, and we probe every single time and put these holes in. And so you're doing in-machine probing, not so much for inspection purposes, but for location purposes that backfeed to the work fixture offsets.
Yes, so I'm updating the work fixture offset, and because we are doing that all on a 4-axis mill, and it's a C-frame mill, as the day goes on, the C starts to tip in.
Yeah, isn't that it?
Heats up. So we chase it back into tolerance, and we chase the center all day long. And without the probe, it is a nightmare.
Yeah, absolutely.
We used to get our scrap wasn't high, but now we have 0 scrap because of the probe. And it takes maybe 30 seconds to do that. So bringing that in every time is, again, it's not the fastest thing, but it guarantees the process, and the process keeps moving.
Well, it is, if you have 0 scrap, it's really fast then.
Yes.
Because ultimately making scrap, making parts real quick and making scrap is a real waste.
Yeah. And then we also have the height setter, the tool setter. Right. So there's a couple 3 millimeter holes that are drilled and tapped in there. So we brake check the drill before the tap comes out every time. And again, It takes seconds to do that.
Sure.
But we have no problems. So it just runs.
So you have tool breakage detection that you call up in your program to double check that tool is still there.
Still there, and you're okay to pull the tap.
You do that after every hole, or is that after every part?
Every part. There's only 2 holes in each part.
I see.
Yeah. So it comes out and does that.
Now, was that on the machine when you bought it? The probing system, or was that retrofitted?
On the one machine, they were added after, but they were added when we bought the machines.
I see.
Yeah.
So it was a decision you made right at that time of purchase.
Yeah. So I purchased all of our machines, always come in with the probe, the height setter, through spindle coolant, obviously coolant beside the spindle, through spindle air, and air beside the spindle. That's our standard. Standard, and it has to at least have the 400 block look ahead on the FANUC and a data server.
Well, in the end, that's, effective technology. And those are really interesting points, because ultimately a new machine shop owner may not realize what he needs. And that is a crucial point that you speak to.
Yeah, we do use it on other parts as well. And especially on some of our overnight die mold cutting, we'll come out and re-probe the corner to make sure, especially on the bigger machines, everything thermally is good before we go in and cut a tight tolerance pocket that has a tight pitch, or, and we just build that in. And it really, really makes the toolmaker machinist job a lot easier. So yeah, you should be taking advantage of those things.
No, absolutely. Is that the Renishaw stuff?
Yeah, all of our stuff is Renishaw.
Yeah. Good stuff. Okay, so that leads us to the next one. How can automation be integrated into metal part production to increase efficiencies?
Mm-hmm. Well, automation too is kind of a big.
Yeah.
What are you automating?
Yeah.
And what are you trying to achieve through the automation? Like the probe is automating, the checking.
It is.
That's automating, and the breakage check is automating. The tool life management also. We always get our machines with tool life management. It's key to kind of track those things. And even I get in arguments kind of with other guys that just have tool and die shops. And they say, well, why are you tracking your drills?
Sure.
Well, because I put them in the magazine, some of them, and you forget how long they're in there for.
Yeah.
Because you're just coming out, just drill a couple holes in this block, drill a couple holes in this block. And then time goes by and you realize, we drilled 1,000 half-inch holes. Well, maybe we should look at the drill. Well, we wreck it in some die mold component, right? And it's not a hard thing to do to set up with a lot of the new machines. So that there is automation. And then,
so do you put tool life management on all your machines?
Yes.
And do you generally measure by time, or do you measure by number of inches they've cut, or how are you measuring the life?
The drills is or
tool change.
The drills is by tool change.
Okay.
How many holes, right?
Right.
Taps, how many holes? But all of our high feed cutters, our finishing ball nose, semi-finished ball nose, all those types of tools, we do them by time.
You do it by time. So then it becomes pretty important that if you've got this on a mill or lathe, that you've got enough tool stations available to have in the extra tools ready in place, right? Yeah.
And even today, I've got something cutting out back right now. We're cutting some hardened H13. And I knew by looking at the numbers before I started that I was good up until the finish tool. So I started the machine when did everything else I had to do, but I flagged it to stop before the finish tool. Changed the finish tool, reset the counter, and came back in here. That was right before I started talking to you, and then it kept going. So it's going right now. So, it helps manage the shop as well. Like you can say, well, instead of having an operator looking at it going, I think this is good enough to cut for the next 4 hours. And, it is going to be good enough.
Well, of course.
And if it's close, you can say, well, I'll just change the tool, because it's cheaper to change the tool than it is to come back in the morning and, we got a terrible finish. We got to let the machine run for another 8 hours. That's 8 hours of time you're never getting back.
It's interesting because I think strategically, a lot of people think of automation as adding an extra piece of equipment, a robot or some other external device to help automate the job. But I think you've made it pretty clear that you've got automation already in place in the machine tool you've got.
Yes.
And a lot of people don't take advantage of that automation.
No, they don't.
And, whether that's programmable offsets, whether that's, as you say, tool life management, I think is pretty much standard on most FANUC controls today, isn't it?
I'm pretty sure it is. Yeah.
Right. You've got tool life management, which manages different, and you've got, obviously all your work fixture offsets to handle.
Yeah.
Even simple things like, bar pullers.
Yeah.
It is an automation.
It is an automation. You don't need the bar feeder. Even actually with the new mill turn we're looking at buying, it. It is prepped for the bar feeder, but the parts we're doing, I'm just looking at it and saying, well, I could just cut them in 3-foot lengths, and if you go down the draw tube, and the parts are so small that the bar puller he's only going to get through maybe a bar a shift. So I don't need to spend all this money on this bar feeder that's a guy's going to walk by at some point in the day and check and, timed out, and let's put another bar in. And that's automation as well, right?
It is. And it again, when we look at this, this whole, we'll call it efficiencies, I think saving electricity and being more efficient is a good thing for a shop. It's not the, what do I want to say? It's not because it's popular. It's because it makes sense.
Yeah.
And if you're not powering another piece of equipment, you're using the current piece of equipment more efficiently with the options that already exist. I mean, it's really no different than somebody who has a cell phone and only uses 10% of it. He just uses it like a phone. Buy a flip phone. It's a lot cheaper.
It's a lot cheaper, yeah. And not only that, right now with the price of real estate, you can't be wasting space in your shop with automation that's not performing every day. If you're going to run a bar feeder, then you better be running 12-foot bars every day.
Yep.
It eats up a lot of space. In that 12 feet, you could put another small machining center.
Yeah, that's also true. Yeah. The space that it takes up. Okay, well, that's great. Yeah, we could go on for a while on this topic.
I go on for a long time with that one. Yeah.
I know. So what role does, CAD, computer aided design, I'm going to say CAD and CAM, play in optimizing the production of metal parts? That kind of ties in with question number 2, really. But I'll let you drive that.
From the CAD perspective, it's funny when we say this, as long as they draw it properly, and label features, hole sizes, what it's supposed to actually be. When you import it into something like Gibbs, you can run the feature recognition and then automate your programming from there, because it's going to find everything for you. I still deal with guys who do not do that from the CAD perspective. They draw the hole, it's the right size, but it's not labeled. It's not. So when you go to interrogate it, you're just looking at a hole. Well, what does the hole do? So there's some automation that could be done there. And if you have a good CAD department, you can make your machining department move pretty good.
Well, I think about this. I think you've got Space Claim, or do you have Inventor? I can't remember what you've got.
We have Inventor, or we had Inventor. I don't think we currently have anything right now. We're in between. That's another topic of discussion.
And I mean, certainly you can do it in Gibbs. But, to your point, if the holes or whatever are dimensioned correctly, then you can certainly use automation in Hole Manager, for instance.
Yeah.
That will go off and figure out what it's got to do to generate the right code if the actual CAD models made sense. If
they made sense. And most of the time, I still find they do not. But the other thing we do on the CAM side is build processes. You have to build the processes, and let's kind of go back to the tooling part of it. In a lot of our machines, you'll find the same tools in the same pocket. You look at tool 20 and just about 7 of my mills in this shop, it's a 2.5-inch 45-degree face mill. And that is tool 20. So when you're programming and you need to face something, you drop the Gibbs tile in there, it populates it. It doesn't matter what machine you're on, it's ready to go. And there's a lot of tools, standard tools, standardizing away home every time. It's most of the time the roughing and the semi-finishing use the same tool.
Yeah,
the same tools over and over again. There's no need to take them out of the machine, retouch them off, reinvent the wheel all the time, right?
Oh yeah. Well, we used to do it all the time with the lathe, right? Tool 1 was always a 80-degree diamond.
Oh yeah, that's mine, 80-degree diamond. Yep.
You're ready to roll 32 thou rad.
Yeah.
And, you always know that station. Maybe station 2 was a 55 or 35.
Yeah.
For finishing, and station 5 was some type of parting tool.
Yeah.
Always put in a place where you know that when it comes down, it's not going to hack something off.
Yeah. We usually have 7 as a drill and 9's a boring bar. And when we're changing the lathe over, sometimes all we do is change the drill. Tool 7, take it out, touch a new one off. Okay, start again.
Yeah. And I'm not sure if you have tool manager IQ, but if we don't, we got to make sure you get it, because that's a great tool for multiple users who are using Gibbs.
I've been kind of looking at it and been meaning to talk to you about that.
Yeah. It's a really, really cool tool. So as far as CAD goes, the question is there for a reason, and they're all kind of tied together. That a machinist comes at a creation of a part from a very different perspective than the typical engineer.
Yes.
And a lot of engineers believe things are just magic. I drew it, therefore you just send it to the cam and it's going to be done.
Yeah.
These are not machinists. You certainly can get in a conversation very quickly and determine you've never machined a part in your damn life, have you?
Very quickly, yeah.
Yeah, of course it's all beautiful and automatic. It's so the machinist that gets in the middle of this thing and says, you've been designing this thing for months and you're expecting it in 25 minutes.
Yeah.
It doesn't work like that.
No.
But if you have a great communication between the engineering team and the manufacturing team, you can suddenly change the dynamic and start producing parts more effectively.
Oh, very quickly, yeah.
And I think that's how it really ties into the CAD side.
Yeah.
Yeah, absolutely. All right, bud. Well, let's get to the next question. How can waste be minimized in metal part production process? And that goes back to efficiencies as well, right? Manufacturing of time and cutting time, like our podcast is called.
Yeah.
What do you think about that?
Just thinking about the waste. Yeah, it just comes back to the efficiency of how you're going to approach the job and try to keep that spindle moving all the time. And now that we've kind of gotten into larger volumes of parts, it's not so much about machining the part. It's also managing the parts that are on the floor and getting them to flow through your building without moving them 7 times or having someone driving around doing that. And that sort of flow in metal part production isn't really talked about that much. They just assume, well, it comes off the machine in 3 minutes. It's $3. Well, no, it's not that. There's a bigger cost there, and there's a bigger there's a lot of waste that happens where operators get dragged away from a machine. And like one example is coolant. Maybe one of my favorite things, coolant.
Is what? Coolant?
Yeah, I hate coolant. I hate coolant with a passion.
Machinist who loves coolant.
Yeah, I hate coolant.
I think we love to hate it.
Yeah, well, you're always checking the concentration. You did different things to top it up. You got to drain coolant tanks.
Bacteria.
Bacteria. Another thing we actually just purchased is an actual proportioning pump instead of a Venturi mixer.
That's
interesting. It actually just came in today.
Really?
And because I was getting tired of, well, how much do I put in? Well, what's it measure? It measures 6%.
Yeah.
Okay, but if I put, how much are you adding and how much is this happening? And then it's too high or too low. And I'm like, this is involving me all the time to heat my coolant tanks. And so we've gone to this system to try to automate it so they can say, oh, I just need 4%. Set the dial to 4%. It makes 4%.
Well, you just introduced another piece of automation.
It is. It's another piece of automation that we've had to put in because it needs to be no questions asked. The operator should just say, I need this and go get it.
That is, you know what, you just sometimes just don't consider that, but that is actually a very smart decision.
Yeah.
You know, in this particular question, kind of where I was going in my thoughts were, you know, buying material. So, you know, the part is this size. So when you're buying material, you often have options, right? The material we have today is 3 inches thick. We don't have, you know, 2 1/8 thick material that you actually need.
Yeah.
So there are strategic decisions you've got to make sometimes, because yes, it's going to cost you more time because you got to get rid of more material. And then that material becomes chips, and then you're going to sell those chips so you can, you know, collect some money at the end of the year and pay for your Christmas party. I remember a lot of shops in the old days used to use their chip fund as their party fund.
Oh yeah.
The party fund. But there's also a point in time where you're going to speak to the engineers and say, hey guys, it might be better off that we started off with a cast part or a forged part.
Yeah, exactly. Or to efficiency again with the material, anything over 3 inches thick, we'll buy closer to size on the thickness of the overall part. If it's under 3 inches, we always buy it so we can hold on to the bottom. Yes,
Right.
it's 1/4 inch thicker, but we walk around the whole part, hit as many sides as we can, and try to just flip it over, take the back off, and send it to the customer.
Yeah.
And I with one of my customers the other day, we actually got into a discussion. Well, the plate's going to cost more money again because I'm ordering the thicker material.
Sure.
Well, it is going to cost more money, but my time is going to be less. My setups are going to be minimized. And to hold all of those tolerances, I'm doing it all at once. You're going to let the machine do what the machine's designed to do, and you're going to get a better part at the end of the day. And you're actually going to get a cheaper part because I'm not going to be setting it up 5 times, trying to square the block up.
Now, is this something that on average, do your customers provide the material, or are you expected to provide the material?
I'm usually expected to provide the material, but then it's kind of 50-50 depending on some of the really large die blocks and die sections. They provide the material, but at that point you're getting a large block that's, 6-side saw cut, and you can't walk around it with a 3-inch end mill because it's 14 inches thick. So you're going the old way of squaring it up.
Yeah, absolutely.
But whenever possible, we try not to square up because it's really slow, and then squaring up is really expensive.
It is.
When you do it on your CNC machines.
Yeah, it is. Absolutely.
We actually purchase our hardened H13. It comes in squared up.
Oh, really?
Yeah, I've heard they offered squaring services. So I said, okay, how much per block? And bring them in squared up and hardened to 48 Rockwell so we can start. And our efficiency is increased immensely because we're not wasting time squaring up blocks.
Wow, that's a cool service. I like that.
Yeah, it takes a little longer to get the material.
But that goes back to planning.
Yeah, it goes back into the planning stage.
Yeah. And customers' expectations.
Yeah, they seem to forget that it takes an extra 2 weeks to get that because it's coming already almost done, right?
Yeah, it's already there. Well, this time is going so fast. I tell you, it's great to talk to you, Keith. So let's get to what are the best practices for maintaining quality while speeding up metal part production. We touched on this a little bit, but yeah.
Again, I think it kind of depends on your part and the skill of your staff, which is going to be the next question of what you need to bring it up to, and to, you got to have all those checks in place, and the gauging is important, and they have to have access to the gauging, and they should know how the gauging works. your production operators. I've been in places before where they just take the part off and they take it in the room and then they tell them it's good or bad. Well, the guy on the floor doesn't understand why it's good or bad,
Right.
or how it got there. You know, they should be part of that process and learn that part of the process. So again, I guess it's what you're trying to measure and what accuracy you're trying to attain to build a process that's pretty robust. To achieve those goals, even through different tool path, to make sure the burr goes the right way, that when your operator is measuring the part, he doesn't have to think about, is there a burr? Because you already pushed it the right way. So when he sets it on the table to measure, it's the right, like the different things you can do. But yeah, that one, I guess, is kind of part dependent, I'm going to say.
Yeah, that would make sense, obviously. You know, maintaining quality, you know, it always used to be a bell curve, of course, for inspection, you know, but if you're producing a dozen parts or you're producing several thousand parts, the way that's managed can be slightly different.
Yeah.
You know, the operator can have his vernier when the part comes out and he can start measuring, so he can double check that, oh yeah, maybe I need to be changing some offsets here.
Yeah.
Or back to your point, if you have tool life management and you know the graduation of the insert wear, you can start to pretty quickly understand that my tolerance is, you know, +0, -5. You know where to manage that tool.
Yeah, where to manage the tool, and even you can also even put in the program with the counter that you can have a message come up to the operator saying, hey, it's 80 tools, 90 is your limit. Like, start measuring the parts now, because maybe it's going to be premature, right? You can force those things now with a lot of the new FANUC controls to do that for you.
Yeah.
I'm going to say even the new Haas control does that. You can get it to talk to the operator a little bit and communicate. Like, that's they have to communicate.
I think the newer generation loves talking to machines.
I think so.
Oh, all right. Our time is really going fast here, but
Okay.
how can the setup and changeover times be reduced in metal cutting?
So we've gone to a system on most of our production machine. We've gone to Lang, and that stud system, you just lift the fixture on and off. You can build the fixture on another machine and bring it to the other machine, and it's within tenths.
Wow.
You can start machining. We've had a lot of really good success with that.
Nice.
We put it on our 4th axis. We have it on our horizontals.
That's on the Lang?
On the Lang, yeah.
And they're affordable.
Yeah, they're not crazy.
Yeah, some of those systems are just stupid expensive.
Yeah, there's a few out there that when you look at them, you're like, I'm not even sure who buys this.
We'll just say it's a 3-color flag somewhere.
Just like this.
My goodness!
Wow. But yeah, no, we've used the Lang, and it's worked well. And the other thing we've used is magnets, permanent electromagnets.
Okay.
And a lot of them you can put pins in for stops, so you can reference it for the operator. Put the block here, boom, it's on. It's not going to go anywhere, and start cutting. So keep it very simple, and you're not questioning how tight is the guy tightening the vise, and did you tighten the clamps? Well, if it's stuck to the magnet on the horizontal and it hasn't fallen on you in the load station, you're good to go.
Well, and that's interesting, because I think, to your point, as long as there's electricity, in principle, it's not going to fall down. And if there's no electricity, then the machine's not running either.
But when you charge it, you need the electricity for it to take it off.
Oh, I see.
So it's permanent. As soon as you hit the charge and it charges the magnet, it's permanent. You don't need the electricity anymore. It's not going anywhere.
And you're done.
Yeah.
So there's no chance of it falling off. Whereas with hydraulics, you could lose hydraulic pressure and clamps could come off and parts could fly all over the place.
Yeah.
We've seen that more than once.
Yeah. The worst I've done with the magnet is I've pushed it because the magnet's always trying to pull it back.
Okay.
It's always trying to hold it, but I pushed the block. And that was just going too hard and not over enough of the magnet pulls. There are limits to it, but it does work in principle really well. And we've actually we square up our really large blocks like that.
Nice.
We hold them from the bottom on the horizontal. We spin them around and we drill holes and they don't go anywhere.
That's fantastic. Yeah. You forget about that, but certainly, I mean, we use vacuum systems to hold down wood on routers.
Yeah.
So yeah, that would certainly make sense for steel parts, wouldn't it?
Oh yeah.
Yeah. Okay. So, what training or skills are essential for operators to enhance productivity? Where do you think you could direct that answer?
With a new operator, as long as they're willing to learn how to measure and pay attention. Get some people in there, it's 10 parts in, they're not even watching it anymore. Like I've had my son is starting to learn now, and
nice.
Well, I teach him when you hit cycle start, it should look the same every time. The tool should come in, it should come down,
and it should sound the same.
Sound the same. The part spinning should look the same. It should look the same in the vise. The tool should be the right number one tool, not some other tool. And put your hand over the feed hold. It takes, like, you're just holding on over top of it. You don't have to push it, but do it. Yep. Like I still do it after 25 years. And there's other guys I know, they still do it.
Yeah.
They know nothing is going to happen, but they hit the button and you watch what's going on. Be aware of what's going on.
Well, I think, the training or skills.
You got to develop the habits.
Exactly. It's no different than flying a plane. You've got to get automatic things in play.
Yeah.
Things should become automatic. You got to know where the switches are. You got to know where things are. Where's single block? Where's optional stop? Where's feed hold? Where's your speed and feed override? Where's emergency stop?
Where's emergency stop? And when do I push it?
Before it comes through the glass.
Before it comes through the glass, yeah.
Yeah, that would be ideal.
Yeah. But I think you just have to teach them, like I said, the same repetitive thing, and you slowly build them up to, when they're setting up a machine, you set it up the same way every time. You always, whether it's you pick up the vise first and set your work shift, and then you touch the tools. Maybe you touch the tools and then you set the work shift. Just do things the same, repetitive, over, and very quickly you can bring someone up to speed and they get to know the control. And that was going back to the education with our local college. They asked us, well, what should they know? And I said, they should be comfortable standing in front of this control, just as comfortable as I am standing in front of a Bridgeport or a manual lathe.
Yep.
This is their machine now for these kids. They're not going back to the Bridgeport and the manual lathe. So when they stand in front of that control with all those buttons, they need to know the control, and they need to be comfortable with using it. And most kids are, because they're more, how do you know what to say when it comes to computers? Like they're not afraid of it. No. They just need to know how to use it.
But the repercussions are also different.
Yes, it can be really bad.
When you're in a CNC control and you're suddenly, things can really go bad. Really bad. It's not a video game.
No, machining sometimes can be a violent sport. It's not good.
No, but that's where I think your point becoming detail oriented, and we're facing this problem everywhere because people don't have the ability to focus for just a few seconds.
Yeah.
And it doesn't matter what it is, right? You call your pool guy to open your pool. Yeah. Does he remember to do all of the things necessary to open your pool? Maybe, but you've got to double check everything because you can't actually count on them.
No, you can't count on them.
Does your irrigation guy come and get your irrigation system working exactly the way you want it unless you double check it? Unlikely. Things have changed over the years.
Yeah.
And that's why I think a lot of companies who are subbing work out to shops like yours really count on the experience and people who are determined to have respect and honor in the work they do so that they actually are diligent and can deliver good parts.
Deliver good parts. Yeah. And proud of what they deliver.
Proud of what they deliver.
Yeah.
What did I had a foreman once tell me, he says, not all parts that come off a clean machine are good parts. And I thought it's kind of interesting that he would say that because, are dirty machines always producing bad parts? But in his mind, if the machine and the workspace around the machinist was kept clean and organized, generally the production quality off of that machine was better than the guy who had the dirty machine and the dirty work table.
Oh, yeah.
And I would say that's pretty true because it goes back to kind of our last question, which is about lean manufacturing. What do you think, in terms of lean manufacturing and keeping the workspace clean and keeping your machine tidy, how does that tie in?
It does a lot. Like I find the cell that we're setting up now, which is going to be mostly running production in this family of parts, we're going to set it up to where what's in there is only what they need. Certain wrenches, certain things. So you're not looking through other things that aren't necessary or pertinent to making those parts. Like,
yeah,
you put in the measuring tools they need, the certain wrenches, the certain T-nuts, the certain setups for the fixtures, and then that's it. So they can just do that. And they're not moving through everything else in the job shop, because in a job shop, there's sometimes things everywhere. And
exactly. I mean, lean is a whole, it's a whole other multiple podcasts. But I think if we just dumb it down and just have, as you say, we talked about tooling and having certain tools in the same pockets or in the same positions.
Yeah.
If the workspace is the way it's supposed to be, if tools are where they're supposed to be, verniers and micrometers, and those are all in the places they're supposed to be, it lends so much to efficiency just in that simple step. And that's what only should be in their work area. They don't, I think long or gone are the days of the big roll around toolboxes. Like we used to have when we were apprentices. They have a huge Kennedy roll around toolbox that you rolled around every machine you were working on. And, but it's not really efficient because also things end up in those toolboxes that other guys don't have anymore. Where's that 3/4 inch end mill?
Yeah.
Keith has a horde of them down in the toolbox.
Yeah. So those things, I think those need to go away, and the shops should just provide at each machine just sort of the tools you need to run that machine, the right Allen wrench set, the right wrenches, the certain things to do what you need to do, and then have a tool crib for everything else.
And that's where I was heading. We have crib-wise, and in North America, it's been slow to adopt this type of idea of having tool cribs. But I think it's going to catch on, because the reality is that's the direction we have to go to become more efficient.
No, we have to, because you can't be looking around the shop. Oh, Al has this cutter and Keith has that cutter, and are we even using it in the job right now? It's in his machine. And
yeah, exactly.
Yeah.
Well, Keith, this hour went by so fast. It's really great speaking with you. It's you're a fountain of knowledge, and I think you were able to talk to younger machinists and hopefully point them in the right direction and give them an idea that they really shouldn't be nervous about starting a shop, but they should be cautious and take baby steps.
Take baby steps and just keep moving forward. And I think there will be a lot of work in the near future as the trend is going right now, but it's not an easy business to run.
No, but we need shops to build robots, don't we?
We do need shops to build the robots. That is key.
I can't wait to have my first robot. Actually, we do have our first robot, Pepper, but I really want one to clean my house. That'd be really handy.
That would be handy, yeah.
Yeah. What was that? What was the name of that robot on the Jetsons?
Oh,
I don't know. Somebody can put it in the comments. I forgot.
Someone will put it in the comments. Yeah.
You know the one I'm talking about. Rosie. That's
Rosie.
it. Yeah. That's funny. That name is used for everything. Rosie the Riveter, Rosie the Robot.
Rosie the Robot. Yeah.
That's interesting. Well, Keith, thanks very much again for joining us. We're going to get Steph back on and really appreciate your knowledge. And we look forward to getting you back on a podcast again soon. I hope you enjoyed your time with us.
Oh, yeah. Thanks for having me, Al.
Good to have you, Keith. All the best.
Okay. I'll talk to you later.
Take care. Bye-bye. There she is. Okay, co-hostess. What are we doing next week? I don't hear you for some strange and odd and unusual reason.
I always forget that the audio is... So next week, we have Tool Talk, choosing the right instruments for CNC success.
Nice. And who's our guest?
We'd like to keep that a little secret, but...
Oh, okay. Well, we could keep it a secret.
No, it's Tony. Tony Bettinini.
Tony Bettinini from California. Nice. Yeah, we look forward to having him on. Well, yeah, super. All right, Stephanie. Well, thank you for co-hosting the show. And Keith, again, thank you very much. You're backstage. And
did a great job.
He did. Yeah, it was really, well, that hour just went bulleted by.
Yeah, it really does.
All right. Good night, everyone.
Good night.
Thank you for joining us.
Bye.
Thank you for tuning in to the Cutting Time CNC Podcast, where precision meets progress. We hope you've gained valuable insights into CNC manufacturing and are inspired to optimize your processes for efficiency and innovation. For more resources and to connect with Al or Stephanie, visit us at cuttingtimecncpodcast.com. The link is in the show description. Remember, the journey doesn't end here. Keep exploring, keep learning, and keep pushing the boundaries of what's possible in CNC manufacturing. Make sure you follow the show on Apple Podcasts, Spotify, or your favorite player to get notified about new episodes of the Cutting Time CNC Industry Podcast.